In this video, you're going to learn how to handle errors inside of your JavaScript code. So imagine that we have a function that takes a number in as an argument, and then we perform some sort of math operation on that number. Everything works well when an actual number is passed in, but what if the person calling the function passes in something else? We want a way to let them know they misused the function, and we're going to be able to do that at the end of this video. Inside of the advanced directory, I'm going to create a new file, and we're going to call this one try-catch, since in a little bit, you'll be learning about the try-catch statement. So try-catch.js. For this example, I'm going to create a simple function. We just need a function in place that at least takes in one argument. So const getTip is going to get the job done. We'll say we calculate the tip based off of one argument, the amount. We'll just use a fixed tip rate in the function. Now we could return easily amount times whatever the tip rate is going to be. Let's say we want to tip at 25%, so 0.25, for example. Now this is going to return a number if a number is passed in. But what if someone misuses the function, passing in something else entirely? Something that gives us an unexpected but potentially still technically valid result. Down below, const result equals, we're going to call getTip, but we are not going to call it with a number. Let's go ahead and call it with a Boolean instead. Then down below, console.log results. Now, based off of what we learned in the last video, we know that this program is actually not going to crash. True equals 1, so 1 times 0.25 should be 0.25. I can run it over here, node try-catch.js, and when I do, I get 0.25 printing. Clearly, this is not what we want. Now, we have two choices here. We can allow this function to stay exactly as it is here, but there are situations where we want to actually perform a bit of type checking. For example, we can use the type of operator that we explored in the last video. So let's go ahead and restructure things. Right here in the function, we're going to start off with an if statement. If, then I'm going to go ahead and check if the type of amount. Now we know that type of returns a string, and for numbers, it returns the string number. So I'm going to check if that string equals number. Now this condition is only going to pass if that argument is a number. If it's not a number, it's not going to pass. We'll run this code when it passes, and all we're going to do is what we did before. We return amount times 0.25. This is the more interesting part. What do we do if the thing passed in is not a number? Now, it doesn't really make sense to return anything. We don't want to return something generic like 0 because people might not be able to actually realize they passed in the bad type. I also don't want to return something like a string or any other type because that can be confusing, and JavaScript actually has a way to handle this problem. This is done by throwing an error. When we throw an error, it crashes our program. We are allowed to provide a message as well as a bit of context as to where the problem was. In this case, it was in this file on some line. So what we're going to do is figure out how to throw our own custom error, letting the caller of getTip know they misused the function. To do this, we use the throw statement. After throw, we provide some more information about the error. Now this could be anything. It could be a Boolean, it could be a number or any other type, but in almost all situations, what this is a string that describes exactly what went wrong. When we're throwing errors, we want to be as descriptive as possible so the person who's actually trying to recover from the error has enough information to do so. Right here, I could say something like argument must be a number. Very clear, simple, short, and straightforward. Now let's go ahead and save the program and rerun things, keeping the argument to getTip still a Boolean. Over in the terminal, I'm going to rerun the program. And what are we getting? We are getting an error. This error is similar to what we saw in the past. Up above, I can see exactly what line it's coming from, giving me some information as to where the problem is coming from. And down below, I can see that the error is getting thrown, and then I have my message after that. Argument must be a number. So when I see this, I can say, oh, I must have passed in something else. I can go back over here. I could adjust that, let's say to the number 2, for example. Then I would be able to rerun the script. The error is fixed, and I'm getting a result that actually makes sense. So using a combination of type of with throw, we're going to be able to add type checking into our functions. Now, if you remember from some of the errors that we saw earlier on in the course, we had way more than just a couple of lines related to the error. When we throw a string, we literally just get that string back as the error message. There is a built-in function we can use though to generate a more comprehensive error. All we have to do is take our message and cut it out. We'll be pasting it in a second. And right after throw, we call error like this. We pass in the string. So the return result from error is what gets thrown, and this is going to include a lot more context about where things went wrong. So let's go ahead and change this back to something that's broken, like the string test, something that's not a number. Then I'm going to save the file. I'm going to rerun things from the terminal. This time, yes, we are expecting an error. What's interesting though is that we're getting more information than before. Now these first 4 lines right here, these are the same as what we had up above. It's the stuff down below that's a little different. This stack trace shows the various pieces of code running to get to the point in the application where the error was actually thrown. Right here, it's showing us that inside of the getTip function, we had an error thrown. That was on line 5 of try catch. This might be pretty useful, but what if you call getTip 15 different times? That does not really give you good information. But if we continue down the file, we can see where that call came from. Here we can see that we called it from try catch on line 8, which is indeed correct. So by throwing a real error, we're getting a bit more context about why and where that one came from. So anytime we do throw an error, we're going to be using the syntax up above on line 5. Now, just because a program throws an error doesn't mean that we have to let our program crash and burn like we're already doing. Not all errors require a code change to be fixed. Think of your phone, for example. If your phone can't connect to the telephone company, then what's going to happen when you try to make a phone call? It's going to throw an error saying you can't make a call right now, you don't have a signal. The lack of signal has nothing to do with the phone's software itself. So what we need in our software is a way to recover from errors gracefully, doing something as opposed to letting things just explode. To do this, we use the try catch statement. Right here, we're going to go ahead and set up a basic version of that. Now the try catch statement looks unlike anything we've seen so far. The good news is though, is that it is pretty simple. Once we see the syntax a couple of times, we'll be able to knock them out no problem. We start off with try, the try keyword, and then we add a set of curly braces. In this code block, we're going to run some code. Now, if that code doesn't throw an error, that's fine. We'll continue on with the rest of the program. If it does though, we're going to add some other code down below in the catch block to run instead. Right here, catch. We add on an arguments list providing just one E, and then we set up another set of curly braces. So this is the boilerplate try catch statement. This is what we're going to be using anytime we're trying to recover from an error. You'll be setting up one on your own in a little bit, so make sure the structure makes sense. Right here, what we're going to do is take the code that actually throws an error, and I'm going to paste it in here. So imagine that I don't actually have this function. The function comes from some sort of third-party library or something. I want to run the function. If it works, great, I'll print this. If it doesn't work, that's fine too. Down below, we can provide some code to run if an error does get thrown. Console.log catch block is running, just to prove that it actually does run. Now we can save things and rerun the script. I'm going to use clear to clear the terminal output, cleaning things up a little bit. Then I'll rerun try catch, and when I do, I get catch block is running. So this exact same code without the try catch block resulted in the program completely crashing. When we introduce the try catch, we can recover by adding some code here, allowing our script to continue on. Just because one part of the program throws an error doesn't mean we want the whole thing to shut down. Now with this in place, we can go ahead and expand on it just a bit further. First up, let's go ahead and prove that when things go well, we still get the result. Right here, let's say I buy lunch and I spend 10 bucks. I would expect, based off of this calculation, to see $2.50 as the tip. I save things. I rerun the script from the terminal. And right here, as expected, I'm getting 2.5 printing. So when the function does not throw an error, this code just continues on, printing the result. When it gets to the end of the try block, it continues on running anything else. In this case, there are no other lines. Notice that the catch code never runs. This only ever runs if the code in the try block throws an error. If it doesn't, the catch block never runs. And this is great. This allows us to do something when things go well and do something else when things don't go well for whatever reason. Now it's challenge time, and for this one, we are going to move into a file we haven't touched in quite some time. In the functions folder, what do we have? We have a grade calc file. We're going to be adding a little bit of error throwing and error handling inside of here. Now, if you don't have this file anymore or yours looks a bit different, that's fine. You can grab this file exactly as you see it from the lecture downloads for the last lecture. Don't grab it for this lecture because that will include the challenge solution. So what you're going to do here is check and make sure that both of these arguments are indeed numbers. If either of them isn't a number, you want to throw an error, throwing an error along the lines of please provide numbers, for example. Down below, what you're going to do is use try catch with your call. If things go well, you're still going to print the result. If things fail, you're going to print an error message to the screen instead. So this is very similar to what we just did over in the try catch file. I just want to give you a bit of experience setting it up on your own. As an extra bonus for this challenge, how about you don't look at the other code? Try to work from memory right here in this file. Take some time to knock this one out. Pause the video, test your work, try it with some valid and invalid values, then click play. How'd you do? Let's go ahead and knock this one out. Up above, we're going to set up our if statement. Right here, if. Let's check if they're both numbers. If the type of score is equal to a number, then we'll use the logical AND operator. Also making sure that the type of total score is a number. Only if both of them are numbers are we going to actually run the code. Now, what code are we going to run? Well, the code that goes in here is just the function code from down below. So I can take it, cut it out, and paste it right in there exactly as it was before. Now, down below, we can add on an else clause, and this is where we're going to throw the error. So throw error, and we can pick whatever message we like. Please provide numbers only. Excellent. Now we can remove all of those empty lines and the function itself is done. What I wanted you to do was to set up some code down below using try catch to print the result if things went well or print a message if something failed. Right here, I'm going to set up my try block, then catch, and then my catch block. And all we're going to do is take the code that we were originally running and move it into try. If it doesn't throw an error, then it'll run exactly as we had it before, which is great. If things do go wrong, we have the opportunity to recover from that error. That might look a little different depending on what circumstances the function is running in. In our case, though, we just print a little message. Please provide numbers or something along those lines. We can actually directly access that message as well. I didn't expect you to do that for the challenge, but you can access that string message using e.message. This property contains whatever string was passed in, which can be useful for situations like this. Well, I did not require this for the challenge. Why don't you go ahead and switch it over just for fun? Now that we have everything in place, we can test things out with our working valid numbers. I am going to cd out of advanced and into the functions directory, and I will use node grade-calc.js to execute it. Right here, I got an F, and that's okay because the result is indeed printing. Valid data was passed in. Let's go ahead and swap out one of these for a non-number and try again. This time I rerun the script, and what do I get? I get my message, please provide numbers only. So there we have it. This is the challenge solution. Now, quickly, I do want to talk about an alternative way we can structure things. So all of this code right here, this was code that was already in the function. So what I can do is take that code and paste it back down below where it had lived before. What we're going to do is switch up how this statement works. Instead of checking for good data and then running the code for that good data, we're going to check for bad data and throw the error. When we throw the error, we already know that everything stops in its place, so the function code down below is never going to execute. So let's see what that would look like. All we have to do is take the code from the else clause and move it up here. So I'm going to delete the curly braces for the current if clause as well as the else keyword. This successfully moved the old else code over to the new if code, and then all we're going to do is switch up the conditions. No longer do we care if they are numbers, we care if they're not numbers. So if the score is not a number, right here, if the total score is not a number. Now this is only going to fire if both of them are not numbers. That's not what we want. We want it to fire if either of them are not numbers, so I'll switch this over to logical OR. So we were able to do a bit of restructuring to get what is, in my opinion, better code. Now we throw the error up above if things go wrong. If not, we don't have to worry about any of that anymore. We can focus on the regular function code down below. All right, that's where we're going to stop for the moment. Now we know a bit about throwing errors and handling errors in our JavaScript code. In the next video, we're going to integrate a bit of error handling into the two applications we already have. I'm excited to get to that. Let's jump right in to the next one.